When we all first start out with photography, we use our cameras as basically a point and shoot. The entire act of taking the picture is composing the shot and clicking the shutter. But, as you've probably noticed, that doesn't always produce the best photographs. So, in the last section we realized that our camera creates good exposures of average subjects. When the camera is confronted with tricky lighting situations or unaverage subjects, it may not produce the optimum exposure. So, let's take a look at the way a camera goes about creating a good exposure. In order for the camera to set the f-stop and shutter speed, it must first know how bright the scene is. And it does this by using a light meter. There's a couple types of meters that we can use. One's called an incident, and the other is called a reflected meter. The incident meter reads light that is falling onto the scene. So, what you're going to do to use it is you take it and you put it in front of your subject, and you click the button. When you click the button, it reads the light that's falling onto the meter. Now, this works pretty well as long as you can get the meter into the same place that your subject is. And in some cases, that's just not going to happen. Here, I couldn't very well run all the way to the top of this mountain and click my incident meter to get an exposure of the way the light is falling on the mountain. I'm down in the shadows. If I had a reflected meter, I could take an exposure more like this. The reason being is that a reflected meter reads light that is being reflected back at the camera from the subject. So, it's going to work in every situation. No matter where you are, you can always take a meter reading. The other cool thing is that it's already built into your camera. You don't have to go out and buy a special meter. But, as with everything else, there are problems with this meter as well. This meter is designed to render all the subjects that it sees as an average reflectance. And not all our subjects are average reflectance. So, you take an image like this, we've got a very dark train, and it's almost near black. Well, when the reflected meter sees this, the exposure that it's going to create actually looks like this. It sees the dark and it tries to make it average, so it lightens it up. Or if you're looking at a white wall, your meter is going to see the white wall and think, gosh, that's awful bright. In order to make that average, I've got to close down. And it's going to produce an exposure that looks like this. Now, the camera meter operates by putting the value, or the subject, it sees into middle gray. Always. Every single time. That's the only thing that your camera knows how to do. So, when it sees a subject that's average reflectance, it's going to make it an average tone. This works really well for all those subjects that happen to be average. If it sees a black subject, however, it'll also turn it gray. And if it sees a white subject, it'll turn it gray. This is the way the camera was designed to work. The term middle gray is a leftover from when film was monochromatic. It was in the middle of the scale between pure black and pure white. Today, we think of it as an object that reflects an average amount of light, or an object that's average in color. So our camera is trying to make everything it sees into an average color or average reflectance. Of course, we don't see in shades of gray. We see in colors. Learning to recognize the average colors is one of the first things we do when learning the zone system. In this diagram, you can see the average colors in the center. The colors to the right are approximately one stop brighter, and the colors to the left are approximately one stop darker. Although all cameras have a reflected meter, not all meters are the same. Most cameras include a couple of different types of meters. Let's take a look at them. Center weighted, valued over matrix, the partial meter, and the spot meter. The center weighted meter is the old standby. This is the meter that was common in most of the pre-autofocus cameras of, say, the late 70s and early 80s. And what it would do is it would take most of its meter reading from the center of the frame, 75%, and it would look at the outside of the frame and take 25% of that into consideration for its final meter reading. And this was a good meter when you got used to using it, but it took in a lot of the frame. The partial meter uses a little bit less. The circle is smaller, and it actually takes 100% right from within that circle. That's a far more accurate meter reading if you're zoomed in on your subject. The spot meter takes that a step further, and it's a very small area that it reads, usually about 3% of your frame, and it takes 100% as well from within that area. This is what most people consider to be the most accurate meter. But of course, if your meter is sitting over a subject that's not an average tone, it'll give you an errant exposure. The evaluative, or the matrix meter, is also an excellent meter for general photography. This will always give you a good exposure unless you're in severe situations or photographing really unaverage types of images, which when you start shooting more and more, those are the types of subjects and lighting situations you want to get into. What the evaluative or matrix does is it uses all these little squares and it takes averages from them and combines them all to create a good exposure. And it'll usually give a little bit of weight to right around where you're focusing. So if you're focusing in the center, it's likely to give the squares that are in red here more consideration. And if you focus to the left, it may move its heavier consideration there, and you could also focus to the right. So this is a wonderful meter, again, for average type photography. But it's a little tough to do the zone system with it. Now, all of these meters work. We just have to be sure what we're actually metering. We want a meter reading of an exact tone, so we've got to be sure that our meter reading is that exact tone. So let's take a look at how we'd work with these meters. In this case, the green grass is a pretty average tone, and so what I'm going to do is take a meter reading of that. What I would need to do if I was using the center weighted meter is I would need to zoom in and fill the frame with the green to ensure that that's what the camera was seeing. If you're using a partial meter, I would do the same thing. I would zoom in and I would take a meter reading right off of that green. The one thing about the spot meter that's nice is you don't have to zoom in as far. You can just zoom in a little bit and get an accurate meter reading. And with the matrix, you really want to fill the frame because you don't know what it's taking into account on its edges. All these types of meters do the same thing. They turn whatever they're looking at into an average reflectance, and they tell us they're doing it. It's always visible in the display in the bottom. When you press your shutter button halfway down, you get to see a little hash mark appear, and most times it'll be in the center, indicating it's going to create a middle tone value out of whatever is in front of your meter. Now, if you're using an aperture priority camera, or rather your camera in aperture priority mode, you can change your aperture or shutter speed and still keep the same amount of light hitting the frame. So in this case, I am set at 1/125th at f16, and the hash mark is in the center, indicating that the bush will become a proper shade of green. It's going to be middle toned. If I change my value from 16 to 11, the camera automatically changes the shutter speed, so it's still letting the same amount of light in, as you can see by the hash mark remaining in the center. Open up again to f8, and again it has changed my shutter speed from 250th to 500, keeping the same amount of light hitting the frame. If you're working in manual, however, the camera is going to shoot at whatever you have it set at. So in this case, the last time I had fired this camera, I was set at 500 at f16, and when it sees this tone here, it's going to put it at a -3 value, which is going to make it almost completely black. So what we need to do is we need to zero out our meter. And in this case, I would open up to 250th at 16, and the hash mark moves, and now its camera is telling us it's going to turn this into a dark green because it's at the minus side. So again, I open up 1/125th at f16, and now the hash mark is in the center, indicating that this average tone is indeed going to become average tone when I fire the shutter. So the first rule of thumb is to know what meter you're using. The second is to find an average subject and ensure that your meter is only reading that exact tone. And the third is to zero out your hash mark on that tone. And that's going to produce a good exposure whenever you're looking at these average subjects. So what happens when your scenes are unaverage? That's what we're going to get into in the next section.